Question 9, clearly an exponential question, so you should be thinking the minute you see something like this is you're going to be taking your natural logs of both sides to solve this. It's a great question to learn, really good. The only thing that can be a bit difficult is getting through some of the words, so let's have a wee read then. So we'll get electricity on a spacecraft and produces power. Okay, so the power, my pen goes, it's 120 E negative 0.0079 T. Okay, where P is the power and that's T years. Okay, excellent. So determine the electrical power initially produced by the generator, the initial production. So for that one, you're saying, well, for an initial production, PT is going to be equal to 120 E to the negative 0.0079, and I'm going to put in 0 for that. Time would be 0 years. Yeah. So anything to the power of 0, because that's going to come out as 0 now, isn't it? E to the 0. So anything to the power of 0 is going to give me 1. So PT is going to be equal to 120. And that's in watts. So you don't have to do all that if you don't want to. You could just give the answer, so says the marking scheme. But I just thought I would show you why that is. So if you start doing a lot of these examples, you start to realise, yeah, it's just this number in the middle, or this number in front of the E. That is my initial amount. Okay. Now it says calculate how long it takes for the electrical power produced by the generator to reduce by 15%. Okay, now there's a few ways you could do this. You could say, well, I know that 120 is 100%, so if I times that by 0.85, I'm going to work out that my power now, if it's reduced, is 102. You could say that, couldn't you? Yeah, you just multiplied this by 0.85 to work out 85%. But you'll notice, when I start to rearrange this, if I do 102 divided by 120, I just get 0.85 E to the negative 0.0079 T. So that's a nice little clue that you've done this right. And a lot of these questions can start you off, can make it just get the starting bit quite a bit tricky, right? Now, if you start doing these, you'll realise once you rearrange, this is effectively the percentage power you've got. So if it was, if it said reduced by 50% or whatever, yeah, you could put in 60 there. Or you could just say, well, 0.5 equals your E function. Okay, so just when you start doing this, you'll start noticing all this. Now, this is the tricky bit. We now need to get this bit down. I can't solve this just now. And this is where taking our natural logs of both sides comes in handy. Okay, so if I take a natural log of this side, 0.85, to balance it, I have to do the natural log on the other side. So I'll take the natural log of E to the 0.0079 T. Okay. Now, the natural log helps us use our log rules, but it helps us cancel out effectively this E here. So what that is, if I've got the natural log 0.85, over here, this is the natural log is then saying that's log of E to the E 0.79 T. That's what that's saying, okay? So you don't have to write this line. I'm just going to show you, what that means for. In fact, I'll do it on that side as well, just so you can see, just so you can see what's going on. Now, if you think about, and again, you don't have to do this, right? What you can do is go straight on to the next line and just say that the natural log of 0.85 is equal to negative 0.0079 T, because these just cancel out, they cancel out, which is the same as, these cancel out, okay? You could just go straight onto that line. But why is that though? What happens there? Well, if you think about this line here, what that's saying is log E to the E negative 0.0079 T equals, now we've always been told, so if I was to do, log 10 of 100 equals what? Well, it's saying 10 to the power of what gives me 100. So this one would then be saying, okay, well, e to the power of what gives me, I'll put the 100 up here, so 10 to the power of what is 100. That's saying e to the power of what is going to give me e to the negative 0.0079t. So up here we're saying, okay, well, 10 to the power of 2 gives me 100, and we're saying e to the power of what is going to give me this e to the, well, it's obviously just the same, it's just that bit in there, isn't it? So that's why they cancel out. So you don't need to know that, right? But that's what's happening. The point you need to know is that you take natural logs of both sides in order that it cancels itself out. And now it's a much simpler solve, isn't it? So now you're saying you've got the natural log of 0.85 divided by negative 0.0079, and that, oops, is equal to t. So if you stick that in your calculator, you should come out with t is equal to 20.57 years. So not bad for 4 marks, especially when, well, 5 if you include the first bit, especially when you consider that you don't need to do this bit here. It was just this line. Okay, so this is a wee extra that you don't need to know about. So really, making sure you take natural logs of both sides and just knowing they cancel out. 4 marks for that. Pretty straightforward, actually. So yeah, I hope that's been helpful.